we want you to stand in one place, quite still, and just observe the bees that you can see in front of you. So 3 feet by 3 feet is sort of what we estimate that normal person might be able to observe in front of them. And that's sort of, you could choose any size area that you want to look at, but 3 foot by 3 foot seemed like a good standard size. And so the grower can go out there, choose the spot where they want to do observations. They answer a few quick questions in the survey about the weather, what their habitat is like around them. So if they record that they're in an apple orchard, and then they can do a quick estimate of how many flowers they're looking at in their observation area.
From the Oregon State University Extension Service, this is Pollination, a podcast that tells the stories of researchers, land managers, and people like you who are making bold strides to improve the health of pollinators. I'm your host, Dr. Adoni Melathopoulos, Associate Professor of Pollinator Health in the Department of Horticulture. I am thrilled to introduce our next guest, Dr. Hannah Gaines-Day, a research scientist in the Department of Entomology at the University of Wisconsin-Madison. Her career has focused on the vital link between landscape health and pollinator success in crops that we also grow here in the Pacific Northwest, like cranberries and apples. Today, she's here to discuss a potentially game-changing tool she helped develop, the Wibee app. Designed to turn growers and citizen scientists into data collectors, Wibee helps farmers estimate real-time pollination activity right in their own field. So let's learn more about how we can put the power of pollination data into the palm of our hands this week on Pollination. Welcome to Pollination.
Thank you.
I'm so glad to have you on the show. And, I really want to talk about this app that you've developed with the team at the University of Wisconsin. Now, with over 2,000 bee species here in the United States, the average person might only be able to recognize a honeybee. And there is a problem, I imagine, when it comes to commercial growers with this identification gap of like the bees that are visiting their crop and, the bees that they recognize. What is the basis of this gap? Like, why is it so hard?
Yeah, I mean, bees move pretty quickly, and if you aren't spending time focusing on what you're looking at, they all kind of look the same, maybe. But it's important for growers, I think, to distinguish them because growers spend money bringing honeybees in. Honeybees in the last few years have had problems. Growers might not be able to get enough, but the wild bees might be doing most of the work anyway. So being able to distinguish if it's a honeybee or a wild bee is important from the grower's perspective to know if the bees they're paying for are doing the work, or if the wild bees are just there in the habitat are doing the work. And maybe they don't need to worry as much about honeybees, or they can focus more on encouraging the wild bees.
Maybe just back up just one sec. You're in Wisconsin, and there are some similar crops. We were just talking before we got started the show. There's some similar crops to here in the Pacific Northwest. What are the major bee pollinated crops in Wisconsin?
Yeah, so the ones that we're focusing on are apple, cranberry, and pumpkin. Wisconsin's the number one producer of cranberry in the US and the world. And then we also have a lot of like diversified farms with watermelons and cucumbers and other crops like pepper and tomato that benefit from pollination. But our big fruit crops are those cranberry, apple, and pumpkin.
We have a cranberry industry both in Washington and Oregon, a much smaller one, but I often will draw on your work when talking with them because there's been such great research done on cranberry pollination in Wisconsin, including this. I'm really excited about this tool. So this YB, that's how you say it, YB, right?
Weeby. Yeah, we say
Weebee.
weeby. Yep, weeby.
So the Weebee, which is spelled Wibee, the Weebee app, gets around this. It doesn't ask for a grower to be a taxonomist. It has these, I guess you call them morpho groups, these bees that kind of look that you could distinguish with a little bit of training by eye, like the large dark bee or the small green bee. How did you come on these groups?
So we wanted a way. So let me back up for 1 second. The Weeby app was developed after conversations with apple growers. So apple growers in Wisconsin wanted to know if they had enough pollination from wild bees alone, or if they needed to depend on honeybees for their crop pollination. And apple bloom is very short. It's anywhere from 4 to 10 days. And we can't be everywhere at the same time looking at which bees are visiting apple blossoms on all of the different orchards in Wisconsin. And so we wanted a tool that we could give to the growers and say, here, go do observations when it's a beautiful sunny day during bloom, so we can help you understand which bees are doing the crop pollination. And so we wanted to come up with categories of bees that were easily identifiable by anyone. So growers, school children, master gardeners, anyone who wanted to use the app, but also that had somewhat of a functional purpose. And so the groups that we have in Weebee, we have honeybee, bumblebee, large dark bee, small dark bee, green bee, and non-bees. And the idea is that those groups sort of represent functional groups. So if any species of bee in the large dark group visits a flower, they're functionally doing about the same job as another large dark bee. So that was our idea behind that.
Says this dual purpose. So these apple growers, they're busy, and it would help them if they could, get a year-to-year tally of the wild bees coming to their orchards. They might be able to cut back on their honeybee orders, or if they don't have enough, they'll be okay. And you're using these recognizable groups, but they may actually be more than just recognizable groups. They may be functionally, you know, uh, pollen loaders of the same type, delivering the same amount of pollen, being big.
Yeah, correct. So if you think of like humans, for example, you might expect that a human who's 3 feet tall could carry so many blocks of wood or whatever, and a human who's 6 feet tall could carry a certain number of blocks. And so it's an idea that, if you have a bunch of people out and we have to move a pile of blocks from here to there, if you have 3 foot tall people, they could move a certain number of blocks at a time. So you could say, okay, if we have 10 visits by the 3 foot person or 10 visits by the 6 foot person, you'd have a different number of blocks moved. It's the same idea with the bees. So if you have 10 visits of the large dark bee, you expect more pollen to move than if you have 10 visits of a small dark bee.
That makes a lot of sense. I have to ask. Listeners know that I'm Canadian. I don't know where Paul Bunyan is from, but not Wisconsin. That's Minnesota.
Well, we have a lot of Paul Bunyan statues in Wisconsin. I'm not an expert on Paul Bunyan, but we do have lots of Paul Bunyan statues.
That's good enough for me. Let's just claim it. Okay. All right. So you're using the app. Like, give me a picture of an apple grower using this app. So what would they do? They'd be in front of a flower or a set
Yes.
of flowers. What would they do?
So the idea is it's a beautiful sunny day during bloom, peak pollination weather. The grower can go out into their orchard, choose a location, and you identify like a 3 foot by 3 foot observation area. The idea behind the 3 foot by 3 foot area is just that our eyes can't really see more than that.
Ah,
Um,
yeah.
because we don't want the observer moving around because that might scare the bees away or affect the bee activity. We want you to stand in one place, quite still, and just observe the bees that you can see in front of you. So 3 feet by 3 feet is sort of what we estimate that normal person might be able to observe in front of them. And that's sort of, you could choose any size area that you want to look at, but 3 foot by 3 foot seemed like a good standard size. And so the grower can go out there, choose the spot where they want to do observations. They answer a few quick questions in the survey about the weather, what their habitat is like around them. So if they record that they're in an apple orchard, and then they can do a quick estimate of how many flowers they're looking at in their
Huh.
observation area.
Okay.
And then stand there for 5 minutes. And every time an insect visits a flower within their observation area, they just click the picture of that Morpho group and it tallies as they go. And after 5 minutes, the survey stops and it'll have a total tally of how many of each of the different Morpho groups visited your flowers during that period.
I have loaded the app on my phone, but I haven't had a chance to try it. So I guess, I would just sit there and I would hit, big B, green B, small. I would just hit these and it would kind of do the tally for me.
Yep, exactly.
Oh, that's really sweet. I imagine in a big orchard that 5-minute observation, that's probably all a grower really has time for. But, one, the orchard might be variable and, might not represent the whole orchard, but you've done validation on this technique. Tell us a little bit about how predictive this is.
Yeah, so let me back up for 1 second. So ideally, we want people to do at least three 5-minute surveys
Ah,
um,
okay.
on a given day. And ideally, they could do three surveys in multiple locations. So maybe they'll do three surveys in the middle of their orchard and they'll do three surveys at the edge of the orchard because we know from other research that you'll have more wild bees on near the non-crop edge of the farm.
So in 90 minutes, you could get this all done.
Yeah.
Yeah,
Yep.
okay.
Yep. And also, so our whole idea with this was that it would be growers who are collecting this data, but we've actually teamed up with crop scouts and they've added Webee surveys as part of their surveying that they're doing when they're out there looking for
Oh,
pests. And so they'll also just add, three Webee surveys wherever are at in the orchard.
oh, that makes a lot of sense. Okay, so that
Yeah.
was
So
the
then
backup. And then moving forward, you've done research to see how this aligns in both cranberry and apple. Tell us a little bit about that research and the validation experiments.
Yeah, so with the validation experiments, we wanted to know, we had a grad student who went out and she counted how many grains of pollen a single bee visits on a single visit to a single flower. This is painstaking work. And then she goes back to the lab and under a microscope counts how many grains of pollen were deposited. And so we use that number to do a big calculation to estimate how many grains of pollen we expect you get for the whole um, bloom period. So for some flowers, they're only open 1 day. For some flowers, they're open 3 days. It depends on the plant. And so we wanted to know how good our sort of back of the envelope calculation is for total pollen deposits compared to how many grains of pollen are we actually getting in a full day. And so for that study, we did a whole bunch of Weebie surveys, and at the same time, we had flowers that were open for the full day. And then at the end of the day, we'd collect those flowers and count how many grains of pollen were deposited. For apple and cranberry, those flowers are open for multiple days, and so we'd put a bag over them. When we get there in the morning, take the bag off so we know what time the pollinator exposure started, and then we'd record what time we picked the flowers to know what time pollinator exposure ended. And then we'd have our Weebie surveys to know what the visitation rate was that day. And we can do
Oh.
our calculation and see if that total number of grains of pollen we actually see matches what we think we should see based on our calculations.
That gives the grower that kind of experiment would allow the grower to kind of have confidence that when they're hitting that, big B button and there was three big Bs that it actually had some kind of, real pollen deposition. Like you said, that so many cords of wood are being carried by this big bee.
Yeah, yeah. And so the idea is if you're out in the orchard and you're seeing tons of bees, so visitation rate is very high, there's lots of bee activity, is that resulting in lots of pollen deposition? And vice versa, if you go out to the orchard and you have very low visitation rate, so very few bee activity in the orchard, does that mean you're not getting much pollen deposition happening in the orchard?
Well, it sounds like a great experiment as well that it's done on two really drastically different crops, apple and cranberry. What did you find?
So in apple, we did not have a great correlation between activity and full day pollen deposition. In cranberry, we had a very tight relationship. This could be due to a number of reasons. Uh, I'm going to start with cranberry. Cranberry flowers usually they release their pollen before the stigma becomes active. And so when you're collecting a flower that has a stigma protruding, um, the pollen on that stigma is most likely not coming from the same flower.
Ah, gotcha.
In apple, uh, the flowers again produce pollen and have a stigma and produce pollen, and some of that pollen from the flower could be landing on the stigma.
Oh, but in
So,
apple, often it's incompatible pollen, so that you can't discriminate between pollen that comes from a pollinizer as from the, selfing.
yeah, so in
Oh.
apple, you need pollen from a different variety to result in fruit set, but you can't tell the difference looking under the microscope which pollen is on that stigma. And so what we don't know from that experiment is how much of the pollen that we see on the stigma came from that flower and how much of it came from a bee.
Yes, I can see the problem. That's tricky.
Yeah, so we're doing a follow-up experiment this season where we're going to be looking at weebie activity and fruit set. So fruit set is maybe a fruit set is a more um, closely related metric to yield. Pollen deposition should be related to bee activity because that's what the bee is doing, it's moving pollen. But since we don't know where that, if that pollen, if some of that pollen is coming from the flower itself and is in not a useful pollen for that flower, looking at fruit set is maybe more useful because it will only set fruit if it gets pollen from a different variety.
Okay, so it would be almost a better measure of compatible pollen transfer than just, taking the stigma and counting the pollen grains on it, because then
Yeah.
you would have more fruit if there were compatible pollen. Oh, that makes perfect sense. That's a great solution.
Yeah, we've done the same stuff we've done in apple and cranberry. We also did in pumpkin, which is kind of a nice system because pumpkin flowers are only open for about 4 or 5 hours and then they're done. And they have separate male and female flowers. So any pollen you find there has come from a bee visit to the flower.
Have you looked at that data yet?
We've not looked at that data
Okay.
yet. We don't know how tight that
All right.
relationship is. Yeah, yeah.
This is really great, and I can imagine. I'll be speaking to the cranberry growers in a month, and I'll link this podcast. And I do wonder if you are growing cranberry in another region, it seems like reasonable that this might be compatible. You should be able to use it outside of Wisconsin. I'm sure as a researcher, your caveats are coming to the fore, but it does seem like this is a tool that could be used outside of the state.
Absolutely. I think the Weeby app can be used anywhere. And even if you're not interested in pollination per se, it's still telling you about bee activity and which bees are there. And I know in Wisconsin, almost all cranberry growers bring in honeybees during bloom. I'm not sure about out on the West Coast. I think on the East Coast, maybe not all of them bring honeybees, and bumblebees are a lot more common. So it could still be useful, I think, from a grower perspective to know which bees are actually out there.
Oh, definitely. I think that is the practice in Oregon and Washington. Honeybees are brought in, but there was great work done by Kim Patton years ago, just showing the high density. I mean, cranberry bloom here happens at a time when many of the bumblebee colonies are at full strength. So you have this really amazing workforce available to pollinate, and it's not in mainstream agriculture. It's like there are these bogs in the forest, so there's a lot of potential there.
Yeah, and in Wisconsin, the cranberry marshes are like huge, large acreage marshes, whereas I know out east they're much smaller. They're sort of based on natural wetland areas. In Wisconsin, they'll change a cornfield into a cranberry marsh.
Oh, will they? Okay, all
It's a
right.
much different landscape.
Hmm.
And I imagine out where you guys are, maybe they're smaller based on more natural wetland habitat.
I think it is.
Yeah,
Yeah, having seen the images from Wisconsin, this is a much smaller. These are much small field size. Okay, great. So
yeah.
I'm gonna sell them on this and get them going and getting some records from Oregon. And I guess looking ahead is does well, I know the answer to this because you've already talked to me about this, but there's applications beyond agriculture.
Oh, absolutely. I mean, there's a lot of interest in bees right now in general, I think. And like I said, we initially built this app for apple growers and other growers of pollinator dependent crops. But actually, our biggest user group has been master gardeners. So the launch of Weebee happened it sort of coincided with COVID. And the master gardeners require a certain number of volunteer hours for their certification. And so when COVID hit, they couldn't do those hours because that's normally at like fairs or farmers markets, and those were all closed down. And so the Master Gardener office in Wisconsin contacted us and said, "Can we use Weebee for our volunteer hours? Can our participants take Weebee surveys in their home garden or at parks or whatever?" And so we've had a lot of adoption with the Weebee app with gardeners, which is pretty cool. We're also we have so much data. We have just like um I think we have 15,000 Weebie surveys right now,
Amazing.
which is great. And also I should mention that all of this data is publicly available. So we don't provide specific location information for privacy reasons, but anyone can go on to the data dashboard that we have and look at the data that's been collected. So if you're interested in a particular flower or a particular crop, you can filter the data and say, oh, which bees are visiting this plant,
Huh.
and it'll give you that data. It'll spit out a nice little pie chart.
Amazing. This is amazing work. I'm so impressed. And it's such a elegant, simple tool. And it's nice to see that it also, it appears to reflect actual pollination that's happening. So it's, it gets beyond this, we have to get a taxonomist to identify all the bees to answer these questions of, crop pollination. This is really perfect.
Yeah. Yeah. Ultimately, what we want to do is we want to come up with this threshold so that if a grower goes out and they take surveys, it'll pop up and say, it looks like you have plenty of pollinator activity for pollination of your crop. Or it'll say, it looks like pollination activity is a little bit low. Why don't you try coming back tomorrow and doing it again? And that can just give growers an idea of whether they're like right on the edge of pollination levels, activity levels, or if they're, doing great, or if their levels are quite low. And that might affect how they want to do their management. Maybe they want to focus on putting in pollinator habitat to encourage the wild bees, or maybe they need to focus on how do we get more honeybees out here because we just don't have the capacity to put in more wild bee habitat.
It does remind me, I think the last time we were talking about this, it reminds me years ago, Frank Drummond had this idea in Lowbush Blueberry of these kind of repeated plots. And for him, it was like a clicker and it was unwieldy. But the idea was that a grower, if they had 4 consecutive years of consistent native bee pollination, that might be a signal to them that they could ease off on honeybee rentals, and I can see how over time you can really get a sense of like, the dynamics of those wild bees in your system.
Yeah, definitely. We've had previous research in Wisconsin have shown that most apple orchards in Wisconsin have full pollination from wild bees alone. And a lot of the apple growers in Wisconsin aren't actually renting honeybees. They either just have a local beekeeper who keeps their hives out there, or they have their own hives. And so for Wisconsin, I think apple growers in particular, they're based in they're in landscapes that support wild bees, which is great. There are other orchards in Wisconsin that bring in honeybees, and there may be more in southern Wisconsin where there's more corn agriculture, soybean agriculture, and they don't have the habitat around their farm to support the wild bees.
I suppose alternatively, it could tell you, it just occurred to me that your honeybee visitations are adequate. Like you,
Yeah,
you actually have enough honeybees. Like it could go both ways.
yeah, definitely. Yep. And I think that could be a tool for beekeepers too, right? To know whether they're putting in enough honeybees into different cropping systems.
Well, this is great, and I can just, imagine the listeners are their head is spinning as well with this. And I guess as a last question, there are all these remote sensing technologies, and I could imagine that this could be replaced by something. I was at a trade show recently, and the things that they have running up and down rows, calculating all sorts of things, is astounding. I imagine this could be also automated and turned into sort of a remote using remote sensors. How have you been thinking about how this app will develop over time?
Yeah, that's a great question. There's another lab in our department that also works in cropping systems, and they have a camera system that they look at visitation rate with the camera. And so we're hoping to, in the near future, look at data that was collected at the same farms, the same days, and compare Wibee and their camera system to see if our 5-minute snapshots with Wibee are giving us an accurate estimate of, for example, the daily visitation rate. The nice thing with the cameras is you set them up and then they just collect data, and it collects data all day. With Wibee, you're only there for a short snapshot, and so you might miss something because you're not there all day. And so we're really excited to see how well our estimates
Hmm.
compare to the video option. There are also sound recorders you can get and put out in your crop field that tells you something about bee activity. We don't have any plans right now to compare how well that estimates bee activity with Weebie app, but that would be another future direction that would be interesting to look at.
Amazing. Such great work. It's been a real pleasure talking with you, and my head is spinning with applications for Oregon and Washington. So thank you so much for planting these seeds in our heads today.
Great. Thanks so much for having me.
Thank you so much for listening. Show notes with links from each episode are available at the website pollinationpodcast.com. www.oregonstate.edu. I also love hearing from you, and there's a form at the website where you can pop in and say hello and give me feedback. If you want to support the show, remember to leave a rating on iTunes, Spotify, or whatever podcast mothership you use. And finally, if you have the means and you want to help support my lab's effort to document bee biodiversity in Oregon, visit OregonBeeAtlas.org and follow down to the donate button where you can make a tax-deductible donation to the Jerry and Judith Paul Native Pollinator Endowment. Every little bit helps. See you next episode.